Hello and welcome to the 8th episode of Medical Physics 101, brought to you by Physical Sciences Consultorium in collaboration with Science for Everyone. I'm your host, Sajid Singh. In today's episode, we're going to explore one of the most fascinating applications of physics in healthcare, medical implants. From pacemakers to artificial limbs, we'll uncover the science behind these life-saving technologies that have transformed modern medicine. Medical implants are devices or tissues that are placed inside or on the surface of the body to replace a damaged body part, deliver medication, or improve bodily functions. They range from therapeutic devices like pacemakers and insulin pumps to prosthetic limbs and joint replacements. The role of physics is crucial in ensuring that these devices work efficiently, last long, and integrate seamlessly with the human body. Let's begin with pacemakers. These devices are used to regulate heartbeats by sending electrical impulses to the heart muscles. The physics of bioelectricity, how our cells use electrical signals, is key here. When the natural electrical system of the heart malfunctions, pacemakers take over, ensuring a steady, rhythmic heartbeat. Another similar device, the implantable cardioverter defibrillator, or ICD, also uses electrical impulses to correct life-threatening arrhythmias. Now, let's move to prosthetic limbs. These are mechanical replacements for missing limbs, and the physics behind them is extraordinary. Prosthetics are designed to restore balance, mobility, and strength. For example, the concept of center of mass and torque is used to ensure the limb moves naturally. Prosthetics are made of lightweight yet strong materials like titanium and advanced polymers that can bear the weight and pressure of daily use. Cochlear implants are another incredible example of physics in action. These devices help restore hearing for individuals with severe hearing loss by converting sound waves into electrical signals. The implant stimulates the auditory nerve directly, bypassing damaged parts of the ear. The physics of sound waves and signal processing is at the heart of how these devices transform sound into something the brain can interpret. Bone plates and screws are widely used in orthopedic surgeries to stabilize fractures and support healing. Here, physics ensures the structural integrity of these materials so they can bear weight and handle stress over time. Similarly, joint replacements, such as knee and hip implants, rely on mechanical physics to mimic the natural movement of our joints, with materials engineered to withstand wear and tear for years. One of the critical aspects of medical implants is biocompatibility, how well these devices interact with the body. The materials used, whether metals like titanium or polymers, need to be non-toxic and durable. They must withstand the forces of the body without causing irritation or rejection. The physics of friction, wear, and tear plays a vital role in ensuring that implants last as long as possible. Designing implants that last a lifetime and minimize complications remains a challenge. But innovations are on the horizon. Smart implants, equipped with biosensors, can monitor vital signs and adjust in real time. For example, AI-powered pacemakers can now learn the patient's heart patterns and adapt to provide better care. The future of implants looks bright, and physics is driving these advances forward. Looking ahead, we're witnessing groundbreaking technologies like neural interfaces that could one day allow direct communication between the brain and prosthetic limbs, or bioengineered organs that could fully replace failing ones. All of these advancements rely on the deep understanding of physics to push the boundaries of what's possible. Medical implants have revolutionized healthcare, improving and saving countless lives. As we've seen today, physics is at the core of how these implants function. Physical Sciences Consultorium and Science for Everyone are committed to bringing you more insights into the fascinating world of medical physics. Don't forget to like, comment, share, and subscribe to our channel. Let's continue to explore these innovations together. We invite educators, researchers, and industry experts to collaborate with us and sponsor such educational initiatives. Let's advance the future of science together. Thank you for watching.